Hello everyone, we are from Group 3 and we are going to talk about the application of introduction of complex analysis in everyday life. Before that, I would like to introduce ourselves. So the members of our Group 3 is, the first one is Triyani Safitri with ID number 410141916, and then Eli Widianti 410141912, and then Ayu Irfa Soraya 41014201333, and Yasmin Fatimah with ID number 41014201337. So the first one is the theory. So in the theory, there are a complex number, and here is the explanation. So, complex number consists of real numbers and imaginary numbers, where the imaginary numbers is defined as the square root of -1, and complex number can be generated from equations ax squared plus bx plus c equals to 0, with solution x12 equals to minus b plus minus the square root of b squared minus 4ac over 2a. For d equals to 0, then the roots are real. And for d less than 0, then the roots are not real because they contain imaginary numbers. So, the roots of the equation include complex numbers. If the discriminant is written as negative d squared, then the complex root is x12 equals to negative b plus minus g square root of d over 2a, where x1 and x2 is called to be sekawan. The next is operating properties mathematics on the complex number. The first one is addition. The equation of the addition of complex number is a plus bg plus c plus dg equals to a plus c plus b plus d times g. And we have the example that is 3 plus 5g plus 2 plus 2g equals to 3 plus 2 plus 5 plus 2 times g, and we will get the result is 5 plus 7g. And the next is subtraction. The equation of the subtraction is a plus bg minus c plus dg equals to a minus c plus b minus d times g. And we have the example that is 3 plus 5g minus 2 plus 2g equals to 3 minus 2 plus 5 minus 2 times g, and we will get the result is 1 plus 3g. The next one is multiplication. So, the equation of the multiplication is a plus bg star c plus dg equals to a star c plus a star dg plus bg star c plus bg star dg. And we will get a star c minus b star d plus a star d plus b star c times g. And we have the example 3 plus 5g star 2 plus 2g equals to 3 star 2 minus 5 star 2 plus 3 star 2 plus 5 star 2 times g, and the result is minus 4 plus 16g. The last one is division. The equation of the division of complex number is a plus bg over c plus dg equals to a plus bg over c plus dg star c minus dg over c minus dg equals to a star bg star c minus dg over c squared minus d squared. It's equal to a star c plus b star d. So since we know that g is the imaginary number that is square root of -1, so g times g is -1, and there is a minus here, so it becomes b star d plus minus a star d plus b star c times g over c squared minus d squared. So we have to make the denominator simple with use of the property x plus y star x minus y equals to x squared minus y squared. Then we have to multiply the denominator by sekawan c minus dg. And to not change the equation, the numerators are also multiplied by c minus dg. The next is the example of the division of complex number. So 2 plus 2g over 3 plus 5g equals to 2 star 3 plus 2 star 5 plus minus 2 star 5 plus 2 star 3 times g over 3 square minus 5 square equals to 16 minus 4g over negative 16. And it's equal to minus 1 plus 1 over 4g. So that's all about the operating properties mathematics on complex numbers.
The next one is form of complex number. Complex numbers can be represented in several ways. In here there are three. The first one is rectangular form, the second one is polar form, and the last one is exponential form. First is rectangular form. If there is a complex number z is equal to x plus iy, where x is the real part and y is the imaginary part, then the complex number can be described in the Argand plan, as we can see here in the picture. R is the line from the starting point to point Z, while theta is the angle formed from the line R with the x-axis. All points on the x-axis represent a real number line. Next is polar form. Assuming that R is equal to roots of x squared plus y squared and theta is equal to arctangent y over x, then x plus iy is equal to r cos theta plus ir sinus theta equal to r parenthesis cos theta plus I sinus theta. To shorten the writing form, the form r parenthesis cos theta plus I sinus theta is often written as r chase theta. The polar form equation becomes r less than theta. Last is exponential form. The exponential form of a complex number is x plus iy will be equal to r e power I theta. This form is obtained from the polar form with the relationship between the trigonometric function and the complex exponential function. We have that sinus theta is equal to e power I theta minus e power negative I theta over 2i is equal to imaginary of e power I theta. And also we have that cosine theta is equal to e power I theta plus e power negative I theta over 2 and it will be equal to real of e power I theta. Since complex numbers have a relation with exponential, therefore, we can find the natural logarithm of complex numbers. Next is transformation equation. The form of a complex number can be transformed from one form to another form. Here are the transformation between rectangular and polar form. The first one is rectangular to polar form. If defined in polar form are less than theta, then in rectangular form, where the equation is z is equal to x plus iy, defined as x equal to r cosine theta and y equal to r sinus theta. Next is transformation equation from polar to rectangular form. There are four types. The first one is if the rectangular form is v is equal to x plus iy, then the form of the polar equation is r less than theta with r is equal to roots of x squared plus y squared and theta is equal to arctangent y over x. The second type is if the rectangular form is z is equal to negative x plus iy, then the form of the polar equation is r less than theta with r is equal to roots of x squared plus y squared and theta is equal to 180 minus arctangent y over x. The third type is if the rectangular form is z is equal to negative x minus iy, then the form of the polar equation is r less than theta with r is equal to roots of x squared plus y squared and theta is equal to 180 plus arctangent y over x. And the last one is if the rectangular form is z is equal to x minus iy, then the form of the polar equation is r less than theta with r is equal to roots of x squared plus y squared and theta is equal to 360 minus arctangent y over x.
Okay, the next theory is RLC circuit. Based on the article, there are three types of electrical circuit. There are resistors, indicators, and capacitors. The component of RLC. There are resistance, reactance, and impedance, also inductors and capacitors. For the resistance, resistance is the resistance exerted by a resistor, and reactance is a resistance that is a reaction to change in current and voltage. And impedance is the whole of the nature of the resistance to current. And then the inductor and capacitors. Inductors are electrical components that store electrical energy in the form of magnetic energy. And a capacitor is an electrical component that stores an electric charge. And next is, what is the relation of voltage and the rate of the change of current through the indicators? The relation obtained from the following equation. V is equal to L times 2di over dt, where V is voltage, L is indicators, and E is current. Inductive reactance, or XL. Inductive reactance can be calculated from the following equation. XL is equal to times 2P times F times L, where XL is inductive reactance, F is frequency, and L is indicators. And then, what is the relation of current and rate of change of voltage through the capacitors? The relation can be calculated from the following equation. I is equal to C times 2 dV over dt, where V is the voltage, C is capacitors, and E is current. And next is capacitive reactance, or XC. Capacitive reactance can be calculated from the following equation. Xc is equal to 1 over 2 times P times F times C, where Xc is equal to capacitive reactance, and F is frequency, and C is farad. The next formula is about impedance and effective voltage. Impedance, or absolute value of Z, can be obtained from the following equation. The absolute value of Z, or impedance, is equal to square root of R squared plus XL minus XC squared. And for the information, XL is the inductive reactance, XC is capacitive reactance, VL is inductor voltage, VZ is capacitor voltage, VR is resistor voltage, and R is resistor. And the effective voltage, or VIV, can be obtained from the following equation: square root of VR squared plus VL minus VZ squared. And the phase angle of the circuit can be obtained from the VL minus VZ over VR equal to XL minus XC over R. And the last is properties of RLC. If the inductive reactance is greater than the capacitive reactance, then the circuit is inductive. If the inductive reactance is smaller than the capacitive reactance, then the circuit is capacitive. If the inductive reactance and the capacitive reactance are the same, then the circuit is resistive. And if the circuit is resistive, then the impedance of the circuit reaches a minimum and the magnitude is equal to the resistor.
Okay, I'm Triyani Safitri, and now I'm going to present about the results and the discussion about complex number on RLC circuits. Okay, and then complex number in RLC circuits are applied when calculating on circuits. One of example is impedance. Next, for the impedance formula, we have Z is equal to R plus GXL plus GXC, or Z is equal to Z capital times exponential I theta. And then to find out whether the current or voltage vibrates first, Ohm laws can be used. And the formula is I is equal to V over Z is equal to V initial over Z capital times exponential G power theta minus phase. We saw that the phase lag current by phase of the voltage. Then complex number transformation form in operation, and then we see in the picture from operation of addition and subtraction we use rectangular form, and then for operation multiplication and division we use polar form. And then for next slide, we have the example, and there's the picture. To calculate total impedance of the circuit, we need to find the inductive reactance, or XL, and the capacitive reactance, or XC. And then for XL, or inductive reactance, we use the formula is equal to 2PFL, and then we get the result is 244,92 ohm. And for XC, or capacitive reactance, we use the formula is equal to 1 over 2 PFC is equal to 1769,28 ohm. And then we need to find the impedance of each component, which is R, L, and C. For ZR, we have the result is 250 ohm. For ZL is equal to 0 plus G 244,92 ohm, and for ZC is equal to 0 minus G 1769,28 ohm. And then we have to add all of ZR plus ZL plus ZC to get the Z total, and then we get the result is 250 minus G 1524,36 ohm. And then when transformed to a polar form, the total impedance become R is equal to the square root of X squared plus Y squared, and then we substitute 250 to X and 1524,36 to Y, and then we have the result is equal to 1544,72. And then for the theta, by using the formula is equal to 360 minus tangent minus 1 y over x, we get the theta is equal to 35h,59. And then for the Z total, we have from this is equal to 1544,72 ohm less than the theta. And if total impedance is known, we can find the total current in the circuit. So we have the I total is equal to V total over Z total and is equal to 0,078 ampere less than minus 358,59.
The next is conclusion. So the first is complex numbers have many applications in real life, one of which is in the calculation of electric circuits. And then the next is complex numbers have several presentation forms, including rectangular, polar, and exponential forms. And then it can be transformed from one to another form. And then an RLC circuit is an electrical circuit that contains resistors, inductors, and capacitors. And the last one is in RLC circuits calculations, complex numbers are used in terms of impedance, current, voltage, and etc. So that's all from group 3. Thank you. Bye-bye.